or not even that long, maybe like 15 years from now, I do really believe in a decade or so, I think it's going to feel really stupid to write your own SQL or to be building your own semantic layers. Welcome, Robert.
Thanks, Joseph. Thanks for having me.
So my first question to you is, what have you been doing? What have we been doing since the hyperquery days? First of all, what happened with hyperquery?
Yeah, I guess for those who don't know, hyperquery got acquired by DeepNote, so we merged with a competitor. Great team, great founder, but we did not join the team. And since then, Joseph and I have spent a considerable amount of time reflecting on the space, on our original mission, on really our beliefs around what analysts and data people should do and how they should operate in an organization, as well as like how this all fits into the AI, into the rise of AI over the last couple of years. So we thought a lot, and then we started another company. So this is what we've been doing.
Are we still thinking about the same thing, about data insights and the last mile problem?
Yeah, I mean, I think in large part, one of the great benefits of having been in that space for so long is that we've accreted this large library of knowledge around the nuances of how people buy products there, how people use products there, what the cognitive blockers are to adoption, what users really want to, how they want to behave and how they should optimally behave. I think having all those learnings has just been deeply helpful in our second pass through the space. Yeah, I guess for you, Joseph, I'm curious. Like, I think a lot of what brought us to this point now was our context around what was happening with the modern data stack, what was happening with AI over the last few years, and a lot has changed, right? I wonder if you have any comments around, I suppose, like what is happening with the modern data stack, what happened with the modern data stack, what is going to happen with the modern data stack, and what does the future of the data space look like?
Yeah, this is one of our favorite topics. And then we've experienced the explosion of tools around this modern data stack philosophy. I think it was circa 2019, 2020, 2021 when things really took off and exploded, especially with the adoption of Snowflake and dbt. I think these were the two, and these still are the two canonical companies in the data space. But I think a secondary movement has sprung up.
No.
I think that secondary movement is the open data format and the open data forces that are pushing for open data formats and an open data stack. And I don't think that is the same movement as the modern data stack movement. I mean, the key example here is Apache Iceberg and folks pushing for open table formats, open catalogs, and so forth, and being able to interoperate between different query engines. So I think if Snowflake really brought ubiquitous separation of storage and compute, I think there is really going to be a separation of table and compute, meaning you could just have one table, your Apache Iceberg table, for example, and have an open data catalog and just have different query engines plug into the different types of tables. So I think for customers, this is great because in theory, I guess you could set up one data lake, your sort of object storage layer, and then you could have all your tables there. And you could have them live forever in this plane, your data plane. And then different query engines could just visit your home and just and you could just fire the query engine if you don't really like the query engine and bring another query engine home. Or you could work with many different types of query engines for different purposes. I think things like Spark might be really good for like traditional machine learning engineering workflows, but something like DuckDB or ClickHouse or Snowflake might be really good for like analytical workflows, and like ClickHouse might be really good for like observability workflows. So I think that's the exciting thing. And I think, of course, the modern data stack folks have been trying to integrate into this paradigm. So like Databricks and Snowflake are moving in this direction. But I think it's going to be there's going to be a new world. I think it's unclear whether the open formats and the openness by themselves will be a big thing by themselves. But I think you and my thesis here is that the open data stack, the open composable data stack combined with AI is gonna be something. There's gonna be something profound here, right? Because AI systems need infrastructure to operate over. Like so agentic data systems need something to operate over, and having open having an open and composable data stack makes a lot of sense here.
Why is that? Why is open data stack better for AI?
I think there are a few things. I think one critical thing is that open systems tend to innovate a lot faster in general, I think. And when things are moving so quickly, when things are changing, new standards are being formed, like MCP is being formed, A2A is being formed, all these protocols are being formed, that you just have to act extremely rapidly. And when standards form, it's advantageous to be working together with the different folks, and open source and open formats really allow for that. And that probably is the singular eigenvector here for why this is important. But I think philosophically, well, before we get into the philosophy, I think there's a second practical reason, and it's because I think data systems want to be free in the sense of enterprises want to adopt things that are open and things that are not going to take your data hostage, basically. Like, who wants to trap their data into Snowflake forever? That sounds terrible. And so at least from a practical, like non-vendor lock-in perspective, open data formats make a lot of sense. And this is no exception for AI systems. And then number three, philosophically, just like software wants to be free, I think data infrastructure wants to be free. Like the systems and standards wants to be free, but I guess the ops could be monetized, and like the infrastructure scaling and the compute could be monetized, but not the actual concept itself or the standards themselves.
Yeah, it feels like this is the logical extension of the concept of separation of storage and compute to actually rift them, where compute is monetized, storage is not only separated but also open, also composable, not vendor locked in. It's like the full rift of the two worlds.
That's right. I think pretty much. I think that storage is really eating into the compute, so to speak. Like open file formats to open table formats. It's like eating more into proprietary compute, and it's like kicking the proprietary compute out.
Yeah.
We're called agentic data. What does agentic data mean to you?
Yeah, this is a good question. I think, obviously we've been thinking about the AI space for the last 2 years. And there's always been this looming question of like, how do data people use AI? And I think it's odd because the two fields are so proximate, right? Like you have like data drives AI, and AI people effectively are data people harnessing the data for a very specific use case. And so you kind of have these two sides of the same person, same field, but there's no real bridge between them, where it's not clear how AI should be leveraged for data purposes. Like we have a bunch of tools cobbled together and tacked onto existing BI tools and IDEs, wherein you have like an LLM that can generate SQL and then like help you act by acting as a co-pilot against your SQL generation, or that the AI can do some maybe generative things against your BI tool or something like that. But it does feel very hack on, and of course, like it's like in my best interest to die on this hill that like you need to build the data system from the ground up to incorporate AI. But I think what we truly believe is that agents should be built, should be purpose built for data systems, and the data systems also have to be perfectly built to support those agents. You can't start with our initial conditions that have been constructed over years of relic nonsense from the modern data stack and this natural evolution of the world without AI, and then expect AI to just kind of glom on top of it and work perfectly fluidly with all the inner workings.
Are you implying that the modern data stack was built to be used by humans, but you need a data stack that could be used by AI?
Yes, exactly. I mean, yeah, like we've talked about this before, but where the line, there's a question of like, where do you draw the lines between systems? And I think the modern data stack did that in a way that drew the lines in a convenient, logical way that made sense to humans. But that isn't necessarily where you should draw the lines or how you should build the systems when you have an LLM that's deeply integrated into every piece of it. And so I think there fundamentally has to be some sort of refactoring of the entire data stack that is AI native in order for AI to correctly support all the things that you might want to do across that entire stack. But yeah, Joseph, I know that like you've had your own thoughts about this, not only like from this more philosophical angle, but precisely in defining like what are the rules of how an agent might operate within a data stack and what that might look like, as well as like how this compares to how existing tools are handling LLMs. Do you have any additional thoughts on this?
Yeah, you're passing the first question back on to me. Yes.
I'm passing the first question right back to you.
Yeah, so what we think is a new layer of the data stack is going to emerge, and that's the intelligence layer. So typically, you think of the data stack as a stack because they're very logical layers of the stack. So the first layer is the data warehouse itself. It's the place where the storage and the compute happens. And maybe there's like a -1 layer where you have the data integration layer. So you have things like Airbyte and Fivetran putting the stuff into the data warehouse. But like, okay, you have the ground floor level, which is the data warehouse. And then inside the data warehouse, you have the transformation layer, which is like one level above that, which is really driven by companies like dbt. And then on top of that, you have the semantic plus the BI layer, which is level 3, level 1, 2, 3. And that is the insights layer. And historically, that layer has been used by humans to create data applications like data dashboards. And then these dashboards were consumed by stakeholders. That was like the stack. That's the stack as is. And then, of course, you have some peripheral things, like these are some accessory-like things that attach to the stack, like data observability, data quality monitoring, data security, data governance. This just sits maybe next to it, like encompassing the entire situation. But I think even above that, there's going to be one more actual bona fide layer, which is the intelligence layer, which is a bunch of data agents running around and orchestrating your entire data stack for you within an organization. That could entail an agent calling the semantic layer so you could get data insights faster, performing deep research, thinking about the data agent, thinking about data security breaches, the data agent interacting with the data observability tools to make sure that your data pipelines did not break. You have data engineering agents building pipelines, helping folks build pipelines better, or triaging issues with dbt, things like that. So I do think that you do need a completely new layer that serves as the meta layer, if you will, over the data stack, the modern data stack, or the open composable data stack, whichever you have. And I think that's where this concept of the storage of the separation of compute and intelligence comes in. I think like the level of abstraction is, I think folks, we've all thought about computers with the abstract of compute, which is very obvious, which is, look, it's been traditionally very hard to analyze like 1 billion rows of data, but it's not anymore. It's pretty much commoditized. You could use ClickHouse or DuckDB, and and compute sums and aggregates on a billion rows of data in 1 second or sub 1 second now. And this is just all open source. So when storage has been commoditized to a large degree. It's not fully there yet, but in 5 years, storage will be commoditized in the sense of there are S3 buckets. You have object storage, you have file storage and things like that. And you could have open table formats and data catalogs on top of that. So that's pretty much commoditized. Then compute is commoditized. You have DuckDB and ClickHouse, things like that, commoditizing compute. So what is left? You need to have something, and I think that layer is intelligence. Like people want to be talking to intelligent systems in interacting with their data, and not directly to the compute itself. And I think we're gonna look back like 10, 20 years later and think like, what fucking like arcane times we lived in where people have to fucking write their own queries and think about compute themselves, right? It's like, what arcane times do we live in where you have to fucking write assembly? And then you're like, oh, okay, object-oriented programming and, such and such. And so I think we are going to think, many years from now, or not even that long, maybe like 15 years from now. I do really believe in a decade or so, I think it's going to feel really stupid to write your own SQL or to be building your own semantic layers. I think we would have failed as a data community if we didn't provide an intelligence layer where that became the de facto way of interacting with data systems. And I think that's why we started this new company, and this is why we're starting this podcast about agentic data, because we want to talk about this as a community. We want to have a discussion around what this new system will look like. And it's really a great interplay of two forces. One is like the open and composable data stack movement, and there's this AI movement. And in conjunction, this is going to be an amazing world.
Yeah, it makes a lot of sense. And I mean, I think, do you have any opinions on how this, like, so you brought up assembly, right? Assembly, obviously, people don't write in assembly anymore because there's better abstractions that sit on top of assembly. But what's curious is that AI can write assembly, of course, right? Like LLMs can write assembly. As this transition happens to LLMs, say writing SQL, do you think that we're going to need better abstractions than say SQL, or are we going to be just sitting there writing? Like, is there like some sort of like global optima where we kind of converge into the right level of abstraction for the LLM and then like rewrite all of the intermediate languages? Maybe it's assembly.
It's abstractions all the way down and up, but I don't think, unless it's just systematically wrong. Like SQL has been, unless it's systematically wrong, it's not going to be replaced. So SQL has been very much battle tested. Every time somebody tried to invent something that is not SQL, it's been destroyed. So it's so battle tested and so simple and elegant that it's probably not going to be replaced by anything else. But what I do see is that we will probably come up with better abstractions on top of the SQL and on top of the semantic model. Like semantic model itself was sort of an abstraction that now is starting to be fully understood as something important. Which is the idea of, hey, let's not directly write SQL. Let's have like an intermediate layer where this layer translates English business concepts into how the data is actually stored and could be queried using SQL, right? So that's already like an abstraction that took some time to develop. And I think we're probably going to, you and I think there's probably going to be the semantic model that is not a semantic layer, which is like a superset of the semantic model, which is how do we, this does not pertain only to data systems, because data systems is really about structured data, right? Like it's about analytical data, structured data. But if you just think about data as a whole, you do need a way to tell the agent, like the AI, hey, when I say this in English, like this really means that these things are stored in these systems in this particular way with this particular context. Like you need a system to tell it that. And I think that's going to expand. So the semantic layer is expand into a generic semantic model for everything. Okay, that's going to happen. So that there's going to be an expansion of that abstraction, and then we have our own views, right? And our own views, like we're calling one of our methods like latent deterministic scaffolding, which is our way of thinking about there being another abstraction between the semantic layer and sort of the base reality here. And so, we're probably not right the first time around. We're probably wrong, but it is an iteration towards that. So, okay, yeah. In conclusion, I think SQL and semantic layer probably not going away. It's just too well established, and it makes mathematical sense that this is useful. There's probably going to be more layers on top that actually enable the AI systems to work. And you and I even figured out that, and the industry has figured out that it's not just one agent that you need. Sometimes it's actually important to have hierarchical agents where you have like a meta agent controlling other agents, and that is actually gets to better performance. So from that perspective, that's already an abstraction. It's just like a hierarchical leveling system of AI agents. So we do already see like more abstractions come up. So I think it's not like a faraway discussion. This has already happened.
Yeah, it makes a lot of sense to me. Like you just generally need, like the LLM needs more declarative grammars that aren't English. English is just so imprecise and ambiguous.
And like we thought about this yesterday, right? In terms of, it's not even like the right way to think about we're speaking English. It is always, it's kind of like, all probability is conditional probability. Like when you're speaking English, there's already an underlying context. Like if I'm talking to you colloquially,
that's what matters, right?
Yeah.
Like that's the thing that matters.
Context. When I say, say, you know what say means. But if I'm talking to you in math or physics, like if I say dense, like dense means something else in physics and math than dense in in colloquial English, which might mean like you're stupid, but like in math, dense is kind of good. Q is dense in R. So we're already saying things with an underlying context, and that's precisely I think what we want to do to AI, right? It's this notion of course you need the semantic modeling, because there's English itself is spoken with an implicit semantic model all the time. And without that, it's really hard to understand what you're talking about. So of course, that's the case in AI systems as well.
Beautiful. So as all this transpires and we build up these grammars and the LLMs learn to use them, and we no longer have to write SQL, what happens to all the people who are currently occupying the roles where you do this manually?
Yeah, I think this is this is $1 trillion question. And I do honestly worry about what's going to happen to people in the next 10 years, because even us, I think even the folks that are literally just spending 16 hours a day building AI systems, I think you and I are already underappreciating how much AI is going to change. So from that perspective, how woefully underprepared are folks in general on the planet? I think that seriously worries me. But as it pertains to the data profession, I think the positive news is that, I mean, we've been working with some Fortune 500 clients, right? And we do see very, very clearly and viscerally that as we have better intelligent data systems, that the demand for data insights are going up and will go up. Like there are many, many things that people want to ask about the data that they have. They just can't, because it takes days or weeks for people to get their answers back. Like if a stakeholder asks a question, like a data analyst will have to spend some time, and then things are prioritized differently. There are not enough people doing this thing, doing the work, and data analytics is also really gated by data modeling. So like cleaning up the data, and that's like really hard. So et cetera, et cetera. So it's really hard to get your answers back. But if that time to insights could be reduced from days to minutes, I think, it's very clear the demand is going to go up, not by 10x, I think, but it's going to be at least 100x in terms of increasing demand. So that's good. So that means that data people will be in demand. But the bad news is I think a lot of the junior level work is going to disappear because it's just going to be replaced by AI agents. And so the strange thing that's going to happen is I think the more senior and experienced folks are just going to get so much more leverage on their time. So they will be even in higher demand. So probably higher pay, higher demand. And unfortunately, probably fewer junior level jobs will exist for data because, it does take a sufficient amount of knowledge to actually be useful now because of AI. So that's sort of the two sides of the same coin.
Well said. So I have to go pick up my daughter in about 2 minutes from school. But maybe as a final question for you, Joseph, what advice would you give to people that are breaking into, say, analytics or data right now in this very uncertain time?
Folks that are in the space right now building tools, or folks who are data analysts, or who are we talking about?
How about both? Either people who are currently in the field or people who are looking to become analysts, data people.
For folks that want to become data analysts or level up in that domain, I think this is actually a really, really good time to get into this domain because data is more important than ever. Not only is it useful for analytics and getting insights from the business, but I think it's also important insofar as it becomes training data for the AI agents themselves. So I think the importance of data has not decreased. It's only going to increase over time. It's going to be one of the most important things in our lifetime is how to deal with data. So, but you have to learn different skills. I think if you're fucking around at Harvard or MIT or Stanford, taking, I don't know, learning about SQL and shit or whatever, and fucking around with hierarchical Bayesian inference, okay, just you need to accept the reality that these things are not important and helpful. And I don't know. I think as a final point, you and I did go to Harvard and MIT and studied all these complex things, but you and I also had to unlearn a lot of the stuff that we had to learn because a lot of things were not practical. So I do think that universities are not going to be as important in the future anymore as folks. Full disclosure, as folks who went to these universities, so we don't have any bitterness here.
Agreed.
And people are going to have a high level of critical thinking to really survive in their careers, which is actually not taught all that well in universities because people are just too fixated on getting good grades.
No, absolutely. Yeah. Very well said. Cool. Well, thanks, Joseph, for your time.
All right. Thank you, Robert. And we'll chat soon.
All right. Bye, Joseph.